Hopefully you guys have had a chance to view the first video going over examples 1 through 6, solving equations that include radicals. In this video, we're going over equations that have rational exponents. Okay, so go ahead and take a look at number 7 in your notes. Follow along with me. And let's see, how do we solve equations with rational exponents? So number 7, we got x to the 1/2 power. So hopefully you guys remember earlier on in the unit, we talked about how rational exponents can be written as a radical symbol. So really what we're doing is the same types of things. We're going to be raising things to certain powers to get rid of those exponents. But the way that it looks might look a little different, but really we're doing the same thing. So here we go, number 7. We've got x to the 1/2 power, which is the same thing as the square root of x. But we're going to keep it with rational exponents for this video. So how would I get rid of the 1/2? So we want to raise something, or we want to raise both sides to a certain power. Okay? But I want to do it in a way that's going to get rid of the radical, or in this case, the rational exponent. So I want to multiply by something that can give me a 1 if possible, or at least something that's not a fraction. Okay, so what times 1/2 is equal to 1? Well, that would be 2. 2 times 1/2 is equal to 1. So if we raise both sides to the second power, that's going to get rid of our rational exponent. Okay? If you're wondering how does it get rid of it? Well, 1/2 times 2, we just said, makes 1. So this is just x to the first. We no longer have a rational exponent. The other side, 7 squared, is 49. So the answer that we're looking for is x is equal to 49. Let's check it real quick. 49 to the 1/2 power on a calculator is 7. Also, like I said a minute ago, x to the 1/2 is the same thing as the square root of x. And the square root of 49 is 7. All right, let's try another one. So x to the 2/3 is equal to 16. So we're going to raise the left-hand side to a certain power in order to make the fraction go away. Okay? So 2/3 times what is equal to 1? That's kind of what I'm thinking about. Well, if I multiply by its reciprocal, it would be 3/2. And anything multiplied by its reciprocal gives you 1, right? So I'm going to take both sides to the 3/2 power. And that should get rid of my my fraction exponent on the left. Let's see. So 3/2 times 2/3, that does make 1. So I've got x to the first. And then 16 to the 3/2. Now you can evaluate that on a calculator, but just like we talked about earlier on, I like to rewrite anything that has a smaller base. I like to rewrite its base. So 16 is the same thing as 4 squared. And now when I look at it in this form, I can see I can multiply the 2 and the 3/2. And that's going to give me 3 times 2 is 6. 6 divided by 2 is 3. So this is just 4 to the power of 3, which is 64. Okay, so if you type this into your calculator, you should have got 64 if you wanted to check. All right, I'm going to plug it in just to make sure. 64 to the 2/3 on the calculator. 64 to the 2/3 power is 16. So I'm confident in my answer. 64 is my answer. Okay, let's try another one like that. So we got 4x, that whole thing's in parentheses, raised to the 1/3, and then plus 3. So just like with radicals, we need to make sure that our expression with the fraction exponent is by itself. And right now it's not because we have a plus 3 on the left-hand side. So I'm going to start by subtracting 3. So 4x to the 1/3 is equal to 2. All right, now that it's isolated, I want to get rid of that 1/3 And I'm going to do that by raising the left-hand side to a certain power. So if I multiplied by its reciprocal, which is 3, 1/3 times 3 is 1. So I'm taking the left-hand side. So I don't get confused, I'm going to use a bracket this time. And I'm going to raise it to the third power. I'm going to raise the other side to the third power. So remember, 1/3 times 3 is just 1. So that's the reason why we're doing that, to get rid of the fraction exponent. So I have 4x is equal to 2 to the third, which is 8. Divide both sides by 4, and we're going to get 2. Let's confirm this. If I plug the 2 in, 4 times 2 is 8. 1/3 is the same thing as cube root. So cube root of 8 is 2. 2 plus 3 is 5. This one does work. All right, one more. So in this last one, I know that we're practicing rational exponents, but this is something that we need to be able to do as well. So this is 2x minus 7, the square root of that, is equal to the square root of x minus 2. Okay, so normally what we would want to do is try to isolate the radicals and then raise both sides to certain powers. Well, in this case, you can't get the radicals together because they're not exactly the same radical. So like we learned in the last section, in order to put the radicals together, they would have to be the exact same radical. But what we can do is we can still square both sides and get rid of the radical symbol and then be able to figure out what x is. Okay? So luckily, or this only works if the index number is the same. And the way that we will set it up, it will be the same pretty much every time. These index numbers are 2's, so we can square both sides to get rid of the radical symbols, and it's going to do it on both sides for us. All right, so square both sides, because that's the index at the 2, and we're left with 2x minus 7 equals x minus 2. From here, go ahead and just keep solving. Subtract x from both sides. Add 7 to both sides. So I'm getting 5. And then I'm going to plug it back in just to make sure that it works. 2 times 5 is 10. 10 minus 7 is 3. So the left-hand side's radical 3. And then 5 minus 2 is also 3. Yes, this did work. X equals 5 is a solution. All right. Hopefully you're finding these videos helpful. If you need to ask more questions, feel free to email me. Or if you want, you can drop a comment within the lesson, and then I'll go ahead and take a look at that. Thanks for watching. Hope you found this helpful.